Namaskar. Friends, we have already finished 4 lectures on this topic of product design and development. So as you know, the course is divided in 4 weeks. So today we are going to end the discussion for week 1, in which we are discussing the 5th lecture related to product design and development. In week 1, our focus was on basic aspects of product design, the need of product design, the product design steps, and the product analysis. So in the last 4 lectures we have already covered most of the parts related to the product life cycle. We have seen that what are the various stages of product design process, and we have also seen the product policy of an organization. So in today's lecture our focus is on, you can see, the product design steps and the product analysis. So we will quickly go through the steps, because there are number of different books written on this topic, and there are number of stages which have been outlined by various researchers and engineers. But we will try to outline the standard procedure which is most common in most of the design process, or most of the design of products, or most of the examples of the product design. So let us see what are the product design steps. So this is something which I have shown in the last class also. We have seen this, that initially you have idea generation, in which you develop an idea or you generate an idea, then you develop that idea in the form of a conceptual design, and then that conceptual design is taken to the detailed design process, and from the detailed design process you come up with a product. Here you can see the kind of gears or cutters which are a final product of an idea which was generated at the initial stage. So product design, basically, to revise, we know that it is the culmination of ideas into the tangible product or the products in their physical form. So you may have an idea and it may lead to a product. Similarly, the products may not be tangible or may not be physical in nature. Sometimes you have a product which is a software, a product which is a mobile app. So different types of products can come because of the generation of different types of ideas. So here you can see you have idea generation and the final product. So our today's target is to go through the various steps that are followed for converting this idea into the final product. So you can see here, this is a product design, various steps that are used for product design. First one is synthesis, sketching. As you have seen in the previous slide, when there was idea generation, some sketch or some conceptual design or conceptual shape was being drawn by a designer. So initial is synthesis, then sketching, analysis means you will do or compare the various ideas, as I have told in the previous lecture that there may be 4 ideas, 5 ideas. Out of those 5 ideas you will take only 2 ideas further. It means there is a scrutiny of ideas, out of which you will select the best idea. So that is the analysis part here. Maybe the ideas may be compared based on their technical merit, they can be compared based on their economic feasibility, they can be compared based on the safety features, they can be compared based on the environmental factors, they can be compared on the basis of legal factors. So there can be different parameters of comparison as well as evaluation, and not all ideas will reach the next stage. Very few ideas will reach the next stage, and I have told in one of the previous lectures the idea mortality rate. Suppose you generate 100 ideas, only 2 or 3 ideas will reach the market, means they will be converted into a physical or a tangible product. So therefore there is a need to generate lot of ideas so that some of them could be converted into the final product. So their analysis or evaluation of the ideas will take place at stage 3. Followed by the selection of the most appropriate or most relevant idea. Then you will do the basic engineering. You will make a rough design of a product using the engineering skills, and some of these engineering skills we will learn during the course of this lectures, not lecture but during this particular course on product design and development. I should tell you that we are into the 3rd hour of our discussion, and we have to do 10 hours of discussion on this topic. So in the remaining 7 hours of discussion, our focus will be more practical in nature, to acquaint you with the various tools that are helpful in the product design process. process. So the basic engineering skill we will develop during this course on product design and development, and that skill is thereby used to make the design of the product. So we will learn some of the tools here at this stage. Then the detailed design is made. Once the detailed design is ready, as we have seen in previous lectures, what is detailed design? You will have all specifications, for example, related to the dimensions of the product. For example, we are developing a chair. So in detailed design, we have all the dimension, that what would be the length of the chair, what would be the width of the chair, what would be the foam height, what would be the backrest, type of backrest, dimensions of backrest, material of backrest, all those designs, the type of support system below the chair, whether it will be caster wheels or it will be a fixed frame. So all those designs with exact dimensions as well as material will be finalized during the detailed design stage. So now you have a complete design. It can be in the form of an engineering drawing, or it can be in the form of a CAD drawing, that is computer aided design drawing. Last class we have seen what are the tools basically used for product design, in which we have seen CAD, CAM, reverse engineering, concurrent engineering. So all those are tools which are used during the process. But here in detailed design process, the outcome will be a CAD file, or it would be an engineering drawing file or in the engineering drawing, which will mention all details, all specifications, all dimensions, all tolerances, all materials that are going to get that product, or that are going to help us in manufacturing that product. Once your detailed design is ready, next stage is the prototyping stage. In prototyping stage, we will try to develop a prototype. As you may have seen the course structure, towards the end of our discussion, we will go to rapid prototyping. And rapid prototyping is one of the most relevant, most common technique which is used these days for making very small prototypes, or the prototype of a complete model that we are going to use for further testing. It can be a functional testing, it can be a non-functional testing. We just want to see that how the product would look like. That can be made using any technique of rapid prototyping. So that is, prototyping will be done. We will learn some of the techniques of rapid prototyping, such as the stereolithography apparatus. We will see maybe laminated object manufacturing. Depending upon the time, we will see how much we can cover in rapid prototyping. So once synthesis, sketching, analysis, selection, basic engineering, detailed design is done, next stage is prototyping. I have already discussed in brief. Next is the manufacturing, and in manufacturing you will manufacture the product full scale. In prototype you will only make few models, but in manufacturing it will be a full scale manufacturing, in which the complete factory will be used and the product will be manufactured as per the design and as per the customer requirement or the demand in the market. Then after the manufacturing, the product will undergo in service operation. For example, now I am using this pointer. Now it is in service. It was conceptualized, synthesized, evaluated, prototyped, manufactured, and now I am using it. So in use, we will say that it is now in operation. So whether it is operating successfully or it is not operating successfully, that will be tested during the operational time, or during the operation. And finally the product development. So I have already told you that product design and development is not a process which is which is, you can say, only stagnant process. It is a moving process. So once the product is designed, the designers will keep on working on innovating, in doing incremental innovations and adding features to the product. So because the value of the product is directly influenced by the features or the functions the product offer, so the designers would keep on working in improving their product value by increasing the functions or sometimes eliminating the unnecessary functions in order to add value to the product. So the product development process will keep on continuing, and it is a continuous process. And you have seen that in the product life cycle, during the maturity stage, the company would definitely love to add new features, to make different types of policies, so that the product remains competitive in the market. So product development, 10th number, is a continuous process which will help us in further improving the value of our product to the customer. And next week our discussion will focus on the various concepts of value engineering which is relevant in product development process. So now let us see these product design steps one by one. We will see just a very brief outline of the various steps, because we have to cover the next stage of product analysis also in today's lecture. Now synthesis, I will just read quickly. I have tried to explain it with the help of an example, that what is synthesis and what is evaluation. Let us see one by one. Synthesis is try to develop different alternatives. Sketching is maybe different alternatives. Here can be the various ideas that you have related to the product. So first part is the different alternatives or different ideas. Next is draw sketches in exact scale for different alternatives. So you now sketch the various ideas that you have, conceptualized the idea. Then analysis, analyze different alternatives with respect to operability, maintainability, inspection, assembling and dismantling issues, cost parameters, production methods. Even I can add legal methods, copyright issues, IPR issues, and then environmental concerns, waste disposal, recycling. You can name any issue, it can be covered here. Analysis, you have the ideas, you can analyze those ideas based on number of parameters, and then you will be left with a few of them, because some of the ideas would get eliminated because of the criteria we have chosen for selection or analysis. So finally selection, we select the best alternative. I should say at this stage we may not be selecting only one alternative, we may be selecting 4 or 5 or 6 alternatives that may be further you can say evaluated for different other criteria. Maybe many criterion we are covering here, but there may be some criterion that may be left for a later stage analysis, but this would lead to just shortlisting of the ideas. We may have 10 ideas, now we have shortlisted to 3 ideas. So those 3 ideas we will take further in our discussion or in our analysis. Then the basic engineering, as I have explained, we will use different tools like DFM, DFA, that is design for manufacturing, design for assembly. We may use DFMA tools, we may use design for quality. All these tools will be used, concurrent engineering, reverse engineering, to come up with the design of the product. So in basic engineering design, we prepare a layout in exact scale, calculate strength of the component, select proper cost effective material. As I have told, now each and every component we will design. Maybe for a chair we can see, we will in basic engineering design we will see that what would be the foam or what would be the combination or thickness of the foam that would be there in the back support, what would be the thickness of the foam that will be there on the seat, what will be the material of the foam, and what would be the back support, what is the material that we are going to use for back support. So for a design of a chair, we will do complete analysis of the strength of the components, as well as we will select the material in the basic engineering design. Then coming on to the detailed design. In detailed design, we will prepare detailed engineering drawing of each component. So as all of you have studied or may have studied the engineering drawing or engineering graphics or computer aided design course, there is a complete different views are plotted, maybe in first angle or third angle depending upon the requirement. So you will have different views of the object or the product. Even the bill of materials is also there, the number of screws and bolts and other things are also finalized, the material that is going to be used to fabricate that job is also finalized and fixed and freezed. So in detailed design, your design is now ready for manufacture. You have found out or you have designed the product as per the customer requirement and as per the technical feasibility, as per the engineering basics, maybe as per the engineering you can say application, we have designed the product completely. I have taken the example of a chair, you can take any other example and see the complete design, and there will be inputs from various engineering sections for the detailed design of the product. And sometimes it can be a multidisciplinary design in which the engineers may be required from civil engineering, from mechanical engineering, sometimes from chemical engineering also. For example, a paint factory would require engineers from mechanical, civil and maybe chemical engineering. So the overall product may require the inputs or skills of various sets or for various engineers. So therefore it is important we focus our attention on detailed design, so that we come up with a design which is feasible, which is technical as well as economically feasible, and which is profitable for the organization. And here number of tools will be used that we will cover in the subsequent discussion. Then the prototype is made. If the option is there, then prepare a prototype and test it. And for prototyping these days, as I have already told, rapid prototyping is a in thing, and there are a number of techniques which fall under the broad umbrella of rapid prototyping. Then the manufacturing of the product. If the prototype is not made, then follow manufacturing steps and solve manufacturing problems and assembly problems if any. So manufacturing problems and assembly problems will arise only if we have not taken care of the DFM or DFA or DFMA, that is design for manufacturing, design for assembly, and design for manufacturing and assembly principles at the first instance. Maybe if we take care of all these things during the detailed design point or detailed design step, all these problems will never occur during the manufacturing stage. So this is a standard process. Therefore we will try to iron out or smooth out or solve all the manufacturing problems, assembly problems during the manufacturing stage. But these things can be eliminated or reduced if we make use of the product design tools at the very basic design stage of the product design process. Then the operation. Once the manufacturing is done, product is launched in the market, users start to use the product. After that there is operation, collect feedback during actual operation of the new product. If any problem exists, try to provide design based solution, also implement lessons in the future design. So continuous feedback from the customers. Many a time you may have seen that the automobile companies, they take their vehicles back and do some retrofitting or change of a component. Why? Because that component is faulty and the design is not as per the requirement and it is creating problem for the customer. So they call the thing back and then they replace it. That is what is highlighted here. If any problem persists, try to provide design based solution, also implement the lessons in the future design. And finally the product development. If any modification can be done, implement the same in the next generation product. So product development process is a continuous process and it will continue with passage of time. Now the last part of our week 1 is product analysis. Quickly we will try to go through the product analysis process. Now many factors have to be analyzed in connection with the development and design. Factors varying in character and complexity. So different types of factors or parameters are there. We will see one by one. And the factors are affiliated with different fields in production and industrial engineering. So these factors may be related to the manufacturing or production, or sometimes from the management point of view, that we usually call as the industrial engineering point of view. So this is a brief summary. This has been taken from a very common book or very most read book on production planning and control by the author Samuel Elian. So this discussion is taken from that particular book. And as per Samuel Elian, some of these factors may be grouped as follows. So when we analyze a product, we can at first have the marketing aspects, then the product characteristics. Like in product characteristics we will see functional aspects, operational, durability and dependability, and aesthetic aspects. In economic analysis we will see the profit consideration, the effect of standardization, simplification and specialization, the break-even analysis, and the production aspect. So majorly the red color points give the 4 major aspects that need to be studied related to the product analysis. Again I am reading: marketing aspects, product characteristics, economic analysis, and the production aspect. So on a broader scale, when you are analyzing a product, we have to keep in mind all these 4 parameters. So we will try to go to them one by one. Now in marketing aspect, once the product is selected, then it is very important to know the marketability of the product. That is, whether it is there exists the demand for that product in the market, or it is just maybe the fancy of the promoters of the company that they want to come up with the product. So marketability is important. All further steps are dependent upon the demand of the proposed product and customer acceptability of the product. So today is a customer driven business environment. So if customers are accepting that product, then we should further go ahead and design the product accordingly. If there is no potential market, then it is wasteful exercise to design and manufacture the product. So all the points can be summed up in one line only, that as per the customer demand, we should design and develop the product. Now if it gives the answer of the following question, what will give the answer? The marketing aspects or the marketing analysis. What will be the expected demand for the product, both the short term and the long term demand, whether the functions that are offered by the product are desirable and acceptable to the customer. So this should be the output of our marketing analysis or the analysis of the market, that what is the demand and what are the functions which are acceptable to the customer. And from the customer point of view also, we can do a further analysis. What is the age of the customer, whether he is an urban or a rural customer, or what is the education standard of the customer. So from customer point of, what is the demographic region from where we are taking the sample. So from customer point of view also, we can do further analysis in the marketing aspect. So what was the second aspect that is most important? That is the product characteristics. So from product characteristics point of view, first are the functional aspects of the product. That is, when the marketing possibilities have been explored, the functional scope of the product has to be carefully analyzed and properly defined. So I am not going to delve too much into the functional aspect. Why? Because we have one complete week on value engineering, and in that value engineering part we will focus majorly on the functional aspect of the product design. So the definition of the objective itself rarely tells us much about the predicted functional scope. So if we say that we are going to take an example of a washing machine. So if we say that washing machine, the job is to wash the clothes, it is one broad functional scope of the washing machine, but it may further have sub functions also, which we are going to see now. Now let us take the example. This example is again from Samuel Elian's book. This is a functional aspect. A washing machine, for example, has a clearly defined objective to wash clothes, which is the functional scope of the machine. This does not state, however, how the washing should be carried out, whether the machine should be capable of heating the water prior to washing, whether rinsing or drying is possible, or both are possible, or they are to be done by the machine, and if so, by what method, and what should be the proportion, be automatic functioning and manual supervision. So what we need to understand here is the broad functional definition of a washing machine is wash clothes. But how to wash clothes, whether using a hot water or a cold water or a combination of both, whether automatic, semi-automatic. So functional definition of a product is very, very important, because it will lead to the design of the product in the subsequent stages. Why? Because we have to use our engineering skills to map these functional requirements of the customer. Customer may give us 10 functional requirements. We have to use the skills to map our engineering design with the functional requirements of the customer. So functional characteristics of any product therefore become very, 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 very important. So the functional analysis of this kind obviously affects the design of the machine, its complexity, its appearance, as well as its price. So when we satisfy the functional requirements of the customer, we have to satisfy them with constraints on the complexity. It should not become too complex, the machine or the equipment or the part or the product. Appearance should be good, as well as the price should be competitive. So therefore it is not easy to satisfy the functional requirements with all these constraints, and therefore we need to study the functional analysis of the product in much more detail. Now let us see the operational aspects. Once the functions are satisfied, the next stage is to make the product easy to operate. For example, I am using this pointer. There are only 3 buttons here. One is to be used for the pointer, this red point moving on the screen. The other 2 arrows give the movement of the slide or flipping of the slide. Most easy to operate, a foolproof design, easy to operate. So whenever we are designing a product, its operational aspects should also be taken into account. For example, when you are driving a car, on the gear lever, your gears, the position of the gears is clearly marked. Suppose it is not marked, then it will become a difficult proposition for any driver to operate the gear lever properly. So the operational aspects of the product are very important. For example, the mixer grinder. In mixer grinder, if the things are not properly mapped or not properly marked or not properly explained to the user, the operation may become risky also, because if you are putting your jar on the mixer grinder, there has to be an indication, or the mixer grinder will only start when you have fixed it properly. If the jar is not fixed properly on the machine, the operation of start should not be possible. So that is operational aspect, that it should be easy to operate as well as it should be safe to operate. So in operational aspects, when we are designing a product, we have to keep these things in mind, that the product should be safe to operate as well as easy to operate. So let us see now the operational aspects. The product is not only expected to perform its functions, which we have already ensured during the functional analysis stage. It should not only perform its functions satisfactorily, but it should be easy to handle and operate at the customers, and it should be foolproof design. If you take me for granted, the mobile phones, if you buy, nobody uses the manual that is given alongside the mobile phone. We take the phone and learn it just by operating it. So the operational aspect means that it should be a foolproof design, that a person with a lower IQ level also should be able to use the design, and even a fool, if he is operating the product, should operate it in the best possible manner, otherwise the product may fail. So foolproof design, the layman's definition I have tried to give you, just to give you an idea that as a designer, what are the factors or what should be our target, that the product should not be misused even if the person is not aware of how to use the product. Many a time, if you go to a hotel and stay there, there will be number of equipment, maybe a hair dryer or a hot water kettle, or there can be other products that are placed there. Now as a customer, if I am going there, I may not have used that product before, but the product design is such, the handling is such, that if you use your common sense, you are able to operate that equipment or a machine. Many times I have seen, I have heard, I have experienced also, if you go to a hotel, it becomes very difficult to find out that which tap is for hot water and which tap is for closed water. But when this product has been designed, it is very easy to write C and H on the tap, so that if the C can be indicative of cold water and H can be indicative of hot water. So this is one basic principle of product design, that when you are designing the product, you should keep this thing in mind, that it should be easy to operate as well as safe to operate. So second point on your slide, you can see the product is used at different operational conditions, and the customers vary with respect to skill and knowledge, and the designer's problem becomes complicated with addition of more and more functions. So one point only combines 3 or 4 points together, that is, depending upon the customer's skill and knowledge, we have to design the product, and if you keep on adding more and more functions to the product, the operation may become slightly complicated, and that has to be taken care by the designer during the design process. Now durability and dependability. Durability is in respect of time. These two factors define the quality and reliability of the product. Durability refers to the length of the active life of the product under given working conditions. So it is in respect of time. Suppose we are buying a jacket, so we would expect it to function maybe for a 3 or 4 year duration. So that becomes the durability of that jacket. Similarly, dependability refers to the reliability with which the product serves its intended function. For example, we take a matchbox. If all 50 sticks are able to light up, we will say yes, this is a dependable organization or dependable company which is manufacturing this matchbox, because all 50 matchsticks have lighted up. On the other hand, suppose only 20 matchsticks light up for that matchbox, we will say not a very dependable product, because only 40% or only 20 out of 50 matchsticks have been able to light up. So that is a basic definition of dependability. So you have durability, You have dependability. So if the product is both durable and dependable, we will say yes, it is a product of good quality and good reliability. Thus the quality of the product is directly proportional to the quality of the inputs and the process to manufacture. So here these 2 points also influence the type of material that is being used or that is going into the manufacturing of the product. Thus it is a function of cost. So durability, dependability is a function of cost. So a product may be more and more durable, but the cost will also increase simultaneously. So we have seen that first we have to address the functional scope of the product, then we have to ensure that it is easy to use, it is safe to use, and then we have to ensure that it is durable as well as it is dependable. And finally we have to see that aesthetically it is pleasing to eye. So aesthetically means it refers to the external look good externally look good aspect of the product, and it is concerned with molding and final shape around the basic skeleton. Most of the time we will see that our bridges are standard run of the mill functional scope only, they satisfy a bridge just to cross the river. But in many western countries, now in India also, we will see some of the bridges have very beautiful designs. So the basic functional scope is to provide a passage to cross the river, but sometimes the design is such that it looks pleasing to the eye. So that basically is the aesthetic aspects of the product design. So it is the external look good, or it should look pleasing to the eye. It helps the sales function of the product by attracting the customers and creating the first impression about the product. So aesthetic aspects are also equally important in product design. So a product will function properly as well as it should look good also. And the designers use variety of tools to build the aesthetic characteristics into the product, such as, now all designers, for example, this particular product, again I am taking this example, may have been white in color, but in order to give it an executive look, a black pigment may have been added to this polymer to make this product. So you add colors, sometimes you provide a particular type of surface finish in order to make it look pleasing to the eyes, and if it is pleasing to the eyes, the customer may be attracted to buy the product. So sometimes the designers use special material, they use color combinations, texture may be given to the surface, and sometimes the packaging is done in such a way that aesthetically the product looks appealing. So it is not only the functional scope or the operational scope or the durability and dependability, but it is also the packaging that matters. So that is, you can say, the product characteristics related to aesthetic aspects. Then the economic analysis you can see. During this analysis we need to address these answers. What will be the amount of investment needed to not only to manufacture but to design and manufacture the new product? What are the estimated production costs per piece we need to calculate? Profit, how much we will get, and whether the prices proposed are competitive in the market or not. So all these things have to be done at the economic analysis stage. As I have told you that there are 4 major stages. First are the marketing aspects, second are the product characteristics, third is the economic analysis, and fourth are the production aspects that we have to take into account. And currently we are focusing on the third one. One is marketing, we have already seen. Product characteristics we have already seen. Third one are the economic aspects that we need to answer all these questions during the economic analysis. That is, what will be the amount of investment, production cost per piece, what would be the predicted profit margin, and what are the prices proposed and how they are competitive with the prices of the other products or the competitive products. Now this is the tools in economic analysis. Many times we use the break-even analysis as a engineering tool. It is taught in various engineering economy courses in all across our engineering curriculum or engineering discipline. Most common tool, break-even point. So during economic analysis we can even do the break-even analysis. We can have a total cost curve. Here you can see, I am just revising, there is a fixed cost line which remains fixed, infrastructure cost and other costs. Then there are variable costs, then there is a total cost curve, total revenue curve, and where the total cost curve crosses the total revenue curve, that point is called as the break even point or no profit no loss point. So usually the companies do the analysis, do all the calculations. They have the data related to the fixed cost, they have the data related to the variable cost, and then based on the total cost and the variable cost, they draw this total cost line. The sales volume multiplied by the profit per product will give you the total revenue. If it is not profit, it can be the you can say the total revenue can be the number of products sold multiplied by the cost of the product, so that will give you the total revenue. So you have a total revenue line, you have a total cost line, and a break even point. On y axis are the sales and x axis is the volume. So we want to find out at what volume we will reach a situation where we will start making profit, because here you can see that below the break even point or less in this direction, when the units sold is less than the break even units, you are under loss, because the total revenue line is less than the total cost line. But after the break even point, you can see the total revenue line is above the total cost line, that is you have a profit area here. This is a standard method, standard technique which is taught to all engineers across all disciplines in all engineering institutes. So we are not going to delve much into this, but the only point to explain here is that during the economic analysis or for preparing a business plan for a particular product or an idea, we need to calculate this break even point, that after how many number of units, sometimes we can say after how many years of manufacturing we will be able to start making profit. So one of the important tools of economic analysis. So then last part are the production aspects. We have seen the first three, that is marketing aspects, product characteristics, and the economic aspects. The last are the production aspects. The design will be converted in the production shop, where it will be transformed into a physical product to be offered to the customer. So idea now can be converted into the product using standard manufacturing processes, sometimes advanced manufacturing processes also. The successful transformation of the design into a saleable product is a challenge for the organization. Even we take into account all the factors that we have covered in the last 2.5 hours, still sometimes it may become impossible for a company to launch a successful product. But certainly if we take into account all these factors, our decision will be an informed decision, it will be a logical decision, and it will help the company to at least reach its target of being break even, that they may not be making lot of profit, but at least they will be able to recover the cost that they have invented in the whole process of product design and development. So at production stage, there are few engineering tools that we will cover during our next lectures. Those will be design for manufacturing, design for assembly, and design for X. So we will see all these tools in the subsequent classes. In week 3, we will see the basic details of these tools with some examples, that how these tools have been helpful in launching a successful product in the market, or how they have been helpful in, you can say, simplifying the process of design. So with this, I think we come to the end of week 1, in which we have taken 5 lectures, or we have discussed 5 different aspects of product design, starting from the need of the product design, to the product life cycle, to the product policy of an organization, to the product design process, and finally the factors or the characteristics, or you can say the objectives to be taken into account when you are designing a product. In today's class, we have seen that what are the various steps of product design process, and what are the various factors, or you can say characteristics, that we need to take into account in context of the product design. So with this, we come to the end of week 1. In week 2, our focus will be on value engineering aspects, and I will try to introduce the various case studies or application areas of value engineering, and that would be an important week for all of you. Why? Because whatever we have discussed in week 1 is mostly covered as a curriculum course in many of the engineering institutes in India, but value engineering is not covered at undergraduate level. So those 2.5 hours of discussion will be very relevant and important for all of you. So maybe we will meet again next time and start our discussion on value engineering. Thank you.